Okay, good morning. My name is Aman Gupta. Registration number is 20BRS1075, and my topic for presentation is A star algorithm. A star is basically a graph transversal and path searching algorithm, which is often used in many fields of computer science due to its completeness, optimality, and optimal efficiency. So, the star in this algorithm basically stands for admissible algorithm. The basic equation this algorithm follows is Fn equals to Gn plus Hn, where Gn stands for the actual cost from the starting node to any n node, and Hn here stands for estimated cost from any n node to the goal node. For the algorithm to work, we have to actually prepare this table. This is the path, G value, H value, and F value. We just Before starting the algorithm, we will just discuss about what is uninformed search and what is informed search. So uninformed search is basically when we do the searching method without the information, and informed searching is when we have some information. The difference is this is time consuming. The time complexity is usually b to the power d, and the informed search gives us a quick solution. The example for uninformed is DFS, BFS, and in informed searching, the examples are A star and best first search. Now, uninformed is optimal, but in informed search, there's no guarantee of optimal solution. So the algorithm basically goes like the table we talked about, that we have to prepare this table. So here's the graph I've taken as an example. The orange values are the heuristic values, and the red values are basically the weights of these edges. So we'll start from S, and this is our goal node, and this is the starting node. So the value of G and H, we will just make this table. We will pick the whatever is the lowest number. So here's we only have one option, so we will pick this. Now from S there are two options. There goes B and there goes C. So we'll add them both. We'll find the value of F. Whatever is minimum, we will pick that. Here it's 14. Now from C, S to C. Now from C we have two options, E and D. So we'll add those points here. Now since we have same values of F, we can choose whatever path we want to take. So let's say we are choosing S, C, D, S, C and D. Now we have only one option, E. We will add E to here. Now we will continue with E. So S, C, D and E. It goes to G. We will add this. Now again we have to choose the minimum value of F. So it's SB here, SB, B goes to F and B goes to E. So we'll add these two. Now again we have to choose the minimum. So we will choose this. So for whenever we choose minimum, we're going to check this particular condition if the head of the path is equals to the goal node. Here in this case, it is equals to goal node. So we will end our program, and the value of F will be basically the cost of traveling from S to G. So when we use informed search, we use it when the state space grows exponentially, or basically if the problem is non-polynomial problem, and this algorithm basically solves the non-polynomial problem converts it basically into the polynomial problem. Now what is the heuristic value? Heuristic value is basically just an estimation or a smart guess. Now how do we find the heuristic value? Well, we have a lot of different methods. Here I've shown three. That is Euclidean distance. Euclidean distance is basically just like the actual distance from any node to the goal node basically. For example, the heuristic value of B node will be given by this. We are basically finding the distance between this node and this node. Another method is Manhattan distance, which is basically just absolute of y2 minus y1 and absolute of plus x2 minus x1. Now we have a general method for this. For example, in the 8 puzzle problem, we have these values as the goal node 1 2 3 4 5 6 7 8, and let's suppose this as any arbitrary node. So to find the heuristic values, what we do is we will just count the number of positions these values need to be shifted to reach the goal node. For example, 1 doesn't need to be shifted, it's at the right position, so we'll add 0. 2 needs to be shifted by 1 here, so we will add 1. 3 needs to be shifted by 1 here, so we will add 1. 6 needs to be shifted by 2, so we'll add 2. 5 is at its correct position, so 0. 4 needs to be shifted 2 times, so 2. 7 needs to be shifted 2 times, so 2, and 8 is at its correct position, so 0. So the heuristic value comes out to be 8. Now the note for this algorithm is it guarantees a good solution, but there is no guarantee for optimal solution. The time complexity of this algorithm is T, V plus E, that is V stands for vertices and E stands for edges in the graph. The only drawback of this algorithm is its space complexity, which is O, B to the power D. It is because it has to store all of the generated nodes in the memory. And this is the algorithm of the A star, like a proper algorithm thing. And that's it. Thank you.